This geometric progression problem states that the numbers 2x plus 3, 6, 7 minus x form the first three terms of a GP. Find two possible values for their common ratio. Now let's get it started. By definition, common ratio is the ratio of two consecutive terms, two successive terms. Common ratio generally can be written as R equals to un plus 1, the term ahead, over un, just the term before it. Which means it could be written as u2 over u1, that's the second term over first term. Could also be written as u3 over u2. That is the third term over the second term. So in this case, the common ratio can be written as the second term being 6 over 2x plus 3, that's the first term, and that must also be equal to 7 minus x, the third term, over 6, the second term. And since common ratio is common, we can just drop the r and then equate the two algebraic fractions that we've got left, so that we have 6 over 2x plus 3. 6 over 2x plus 3 equals to 7 minus x over 6. Then when we cross multiply this, we're going to be having 2x plus 3 multiplying 7 minus x, so we can put them in parentheses. Then 6 times 6 gives 36. We open the brackets, the parentheses on the left hand side. That's using 2x to multiply 7 and to also multiply negative x, before we use 3 to multiply 7 and to multiply negative x. So that we have got 14x, that's 2x times 7. 2x times negative x will be minus 2x squared. Then plus 3 times 7 gives plus 21. And plus 3 times negative x gives negative 3x equals to 36. We rearrange and bring 36 to the left hand side. Putting the highest power of x first, we have negative 2x squared plus 14x, then minus 3x plus 21 minus 36 equals to 0. So we have got negative 2x squared, then plus 14 minus 3 gives plus 11x, and 21 plus 21 minus 36 gives minus 15 equals to 0. We can multiply through by negative 1 so that the leading term is a positive 1. The leading term is 2x squared. But here we have negative 2x squared, and such that negative 1 times 2x squared is going to give us 2x squared. Then the plus 11x becomes minus 11x, and the negative 15 becomes plus 15. 0 remains unchanged because it's neither positive nor negative. Now we are left with a quadratic equation, 2x squared minus 11x plus 15 equals to 0, that will solve for in x in order to know the value of x. To solve this by factorization, we first find the product of 2 and 15. That gives us positive 30. And we're going to be needing the factors of 30. So we're going to be needing the factors of 30, and whose sum will give us the middle term, negative 11. So these factors, without wasting time, should be negative 5 and negative 6. When added together, will give negative 11. The quadratic equation becomes 2x squared. Then instead of negative 11x, we're going to be writing negative 5x, so minus 5x minus 6x and plus 15 equals to 0. We can double group the four terms we have in 2's so as to know what to factor out. Now from the first group, x could be factored out. Then in the brackets we have 2x minus 5. From the second group, we could factor negative 3. We are factoring negative so that we can have 2x minus 5 in the second bracket as well. So when we factor negative 3, we have 2x minus 5 equals to 0. Now 2x minus 5 is a common term, a common term or expression. So we factor it out, 2x minus 5. So we factor out 2x minus 5. and in the second bracket we're going to have x minus 3, and that's equal to 0. Now when a product like this is 0, it could mean that either one of them is 0 or both are zeros. So 2x minus 5 could be 0, or x minus 3 could be 0. So when 2x minus 5 is 0, it means that 2x will be 5, or x will be 3 for the second one. So if 2x is 5, x is 5 over 2, when we divide by 2, both sides by 2, or x is 3. So we already have two values for x. Now we want to find the values of the values that the common ratio could take. Then you will recollect from above that we had two equations for the common ratio, where we said r could either be 6 over 2x plus 3, or it could also be 7 minus x over 6. So we put in the values of x into any of them in order to get the values of r, but we're going to take them one after the other. Let's use the second one, 7 minus 6. It looks easy a bit. We also learn to work smart when we are doing mathematics. We don't want to put ourselves into unnecessary stress. So when x is 5 over 2, r then is going to be 7 minus 5 over 2, everything over 6. And this is going to be 7 minus 5 over 2 should give us 14 minus 5 over 2. So the numerator becomes 14 minus 5 over 2, and we are dividing this by 6 in the denominator. So that 14 minus 5 is 9. So we have r to be 9 over 2. Then divided by 6 can be written as times 1 over 6, where we can use 3 to reduce 9 and 6 as a common factor, so that we have 3 over 4. That's the first value of the common ratio. For the second value of the common ratio, we consider the case when x is 3, the second value. Now when x is 3, r this time around is going to be 7 minus 3 over 6, still using as 7 minus x over 6, and that's 4 over 6, which is 2 over 3. So that way we have found the two possible values for the common ratio. We can just conclude by saying that the two possible values for the common ratio of the common ratio are 3 over 4 and 2 over 3.